Everybody, how are we doing today? So we are going to start to learn another power rule. So remember, we are in chapter 7, and this is 7.3, chapter 7, section 3. We've already covered a few of them. So we've covered the zero power law, that anything raised to the power of 0 is 1. We've covered the negative power law, which basically states if you have anything that's raised to a negative power, we take the reciprocal of it, and then that power can become positive. And we covered yesterday was the multiplication of power. So like n to the second times n to the second, base stays the same. We add those exponents. It becomes n to the fourth. Today we're doing the power to power rule. So power to power rule is an interesting one. And sometimes we look at this and it can be confusing, but if we take it, again, one step at a time, deal with one variable at a time, deal with each of the coefficients on these variables at a time, it's not so bad. Everything is doable if we try and we break it up into smaller pieces, okay? So here is our notes or the stars for the day. It says the base will stay the same when we have anything raised to a power up to a power. Base stays the same, and this time we are multiplying the exponents. All right, base stays the same, multiply the exponents. But we also have to be very careful here, okay? Again, be careful. Do each piece on its own. The most basic of examples, and I'll show you this, and I've already have it all written out, is this is your example. You have n to the second power, and then that whole thing is raised to the power. These are generally, power to power rule is, it really is given away because you see parentheses. Power to power rule will always have parentheses. And there's usually something with a power inside, and you have a power on the outside. So again, here our base, this base here is n. So if the base is n, it stays the same. And then we multiply these two powers together. So n stays the same, that's the base. And the exponents were 2 and 9, so we do 2 times 9. And then we do our final simplification. So 2 times 9 is 18. That's the easy one single individual. Okay? Let's take a look at this now. We have two examples. I got the examples today side by side because these aren't a very long and drawn out one. Okay, we look at this and we have to be very careful. So before we start jumping into it, let's look at our problem, read it over carefully, identify the pieces that we know. I can see right here that we have a coefficient of -2. And I can see that we have a variable a, and it's being raised to the third power. So the base is a, and the power is 3. Now notice, see the set of parentheses here? We have parentheses. And outside these parentheses, we see another power. This is the giveaway. When you see this, you know it's going to be the power to power rule. Power to power rule. All right, so how do we tackle it? Well, the first thing we have to do is look. The rule stated up here, the base stays the same, multiply the exponents. But look, we also have a coefficient. So basically, this is being applied to both the coefficient and to this. Remember, this is technically, there's a 1 here. 1 times 8 is 8. Or you were just raise the coefficient to that power. So let's do that. We'll have -2, and it is in a set of parentheses, so that negative is included, raised to the 8th power. And then we're going to have this. Raised to the 8th power. So we have to be careful when we look at this, guys. These are problems that are very careful. If you have a calculator, you are more than welcome to use it for this, because this is a high number. If you're doing this, -2 raised to the power of 8, that's -2 times -2 times -2 times -2, basically multiplied 8 times in a row. we need to use our calculator for that one. All right, so I can get mine to turn on. My calculator doesn't want to work on here. I'm going to pull up the calculator on the computer. So, and be careful when you input this into your calculator. You have to input a -2 in a set of parentheses. I think I did that. Let's try that again. So open a set of parentheses, -2, and then we're going to raise that to the power of 8. So if you're raising something to the power of 8, this calculator, again, it's different than the ones we used in class because my normal class calculator isn't working. You raise it to the power of 8. And that comes 256. All right, and now we have here, we have a to the 3rd power being raised to the 8th power. This is the power to power part. This is the one that we sit here and our base is a. And we have to do 3 times 8. And then we simplify one more time. 256. And 3 times 8. 24. Okay. Very simple. We do it step by step. We take each piece individually and carefully work our way through it. Let's look at this next one here. Notice the difference here. This time, this coefficient is sitting outside of that set of parentheses. So unlike this one, we are not having to deal with making sure that we're fully distributing that 8 to each piece there, okay? So this one here, we have -2. It carries down. And then we have this is we can go right into our power rule. This is a power to a power. The base is going to stay the same. And then we multiply the 2 exponents together. And then we're ready to simplify. Base stays the same. And when we do 2 times 7, hopefully we all come up with 14. That would be your final answer. And this is our final answer. It's a good idea to make sure you're boxing your answers in, especially when you're doing work. All right. So if we look at this again very carefully, we took this one piece by piece. Notice this one is less work because we didn't have to make sure that this power of 8 was being done to the coefficient as well, because it sat outside of the set of parentheses that affected that power of 7. Now we're going to look at this next one. Okay, so now look, we have more than one variable and an exponent all sitting inside. So this is a very careful one here. This is going to be -7 wrapped in a set of parentheses raised to the 3rd power. Then we have the x to the 4th power. Pi to the 3rd power. We made sure that we fully applied this exponent to each individual piece within the term, the coefficient and each of the variables. Well, -7 raised to the power of 3. Again, guys, so you can do this on your own. You're going to notice something interesting here. So this is -7 times -7. times -7, or this becomes what, 49, positive 49 times a -7, 49 times -7, -343. All right, -343. Here's our power rule. Base stays the same. Multiply those two exponents. Base stays the same. Multiply these two exponents. And then you can finish your simplifying on out. Okay, guys, this is taking it absolutely every single step by step, not skipping any directions or any steps or anything like that. 4 times 3 is 12. 3 times 3 is 9. That would be our final answer. And again, just like the last time when we did it yesterday, as we start to get a little bit better, a little faster at these, we don't have to make it as painful as a process. We just have to take it carefully. So we can start to do this, like 4 raised to the power of 3. Again, this is a part, like you might have a calculator on your test, you're okay to use it. 4 raised to the power of 3. 64. Or you could have done 4 times 4 times 4. Either way. Okay, now I have m is the base. I'm going to multiply those together. 5 times 3 is 15. The last one is an n. Now remember, guys, this was here for a reason. There's that little invisible 1. Okay, 3 times 1 is 3. And like that, we have simplified this problem, but without having to show these on all these steps. Now, these steps are fantastic. Remember, this is the first time you guys are doing this. So following steps is a great idea. I suggest at least your first few problems, make sure you're doing step by step by step. When you start to get the hang of it, and you know you're going to get the hang of it, I know you will, then you can start to get a little more less step-oriented and more like visual cues in order to remember what you're doing. Look at these last two. Oh, look at that one. We've used weird variables. What is this? The Greek letter pi. What is this? The Greek letter lambda. Guys, it's okay. There's no big deal. But because this is weird, these are not things we normally do with. Let's be careful with this one. Very careful. So we're going to do it piece by piece again. 3 raised to the power of 2. Then we're having pi squared raised to the power of 2. And then we're going to have lambda cubed, or to the power of 3, raised to the power of 2. Now we do our simplifying. Well, 3 squared. 3 times 3 is 9. Our variable is pi. Watch, here's another. Maybe this is okay. You can do this. All right. 2 times 2 is 4. Our next variable, lambda. 2 times 3 is 6. So maybe if you're not ready to go from this to this, you can do an intermediate stage and show it like this. So you're starting to prepare yourself on how to think more mathematically, how to slowly start to get faster as you compute these problems. All right, let's look at this one here. We're going to, what did they do to us now? Now they gave us 1, 2, 3 variables and a coefficient all inside the set of parentheses. It's okay. I have confidence. I think that we can get through this. So we need to, and I'm going to do, again, watch. I'm going to make sure I don't want to miss a piece here. So I need to do the coefficient and raise it to the power of 3. Then I need to do this to the first variable. And I do not want to make a mistake, so I am going to use a little bit of shorthand, but I'm going to make sure that I'm capturing everything I need. 3 to the, on that y. It's y to the 4th. Raised to the power of 3. And then the last one is 3 to the z. That's z to the 5th. Raised to the power of 3. All right, now as we sit here now, it should be much easier. We broke this problem here apart into all of the individual pieces, the coefficient, the different variables that make up that term. And we've applied that power of 3 to each place. Now we can start to do the rule. So the coefficient is the easiest. The coefficient is just, it's 2 raised to the power of 3. So that's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. This one here, again, the base stays the same. We're going to multiply these exponents. The base stays the same. We're going to multiply these two exponents. Last one, z, our base stays the same. And then we multiply these exponents. So 5 times 3 is 15. And just like that, we have finished this last problem. One that looked even worse than the rest because it had more pieces, but when you set it up and you stay organized, the organization is key, okay? And that works for math, that works for all your classes. Staying organized, keeping things in nice, neat order, whether you're having to use each individual step or you're learning, you train yourself on how to use more visual cues without having to use each individual step, or you use a little combination of both, like these problems. A couple of different ways to tackle a problem, all the same way, and all get the same result. All right? Your homework, guys, will be in Delta Math, deltamath.com. It'll be titled, appropriately, Homework 7.3. So it relates to the notes, so you know which one it goes with. Have fun. Try to get that homework done.